Hello, this is Mr. Stansbury. I'm going to take you through a word problem on solving a system of equations, just to kind of help out a little bit. Okay? So here's our example. Lori was partway up an escalator when her friend Evie realized that she had Lori's keys. Evie, who was still on the ground floor, tossed the keys up to Lori. The function f of x equals negative 16x squared plus 25x plus 5 models the height in feet of the keys x seconds after they were thrown. Use the information for items 1 through 5. Now, it doesn't ask you to draw a picture, but I'm just going to draw a picture just so I kind of get an idea of what's going on here, right? So here's our little escalator. Here's one person going up the escalator. The other person is still on the ground, and they're going to toss the keys up to the person on the escalator, right? So just so we kind of get an idea. When the keys are thrown, Lori's hands are 9 feet above ground level and moving upward at a rate of 0.75 feet per second. And their hands are 9 feet above ground. Write the equation of a function g of x that gives the height of Lori's hands compared to ground level x seconds after the keys are thrown. Okay, so just to make sure that we're clear, Lori is the one that's on the escalator. Evie's the one on the ground. So when she throws when Evie throws the keys, Evie's hands are 9 feet above. Here's the ground, right? Ground. 9 feet above the ground level and moving upwards at 0.75 feet per second. Okay, so to write an equation for that, what we're going to have is let's see, g of x is going to equal, so she's starting at 9 feet above, and then it's gaining 0.75 feet per second, okay? So, and it's x seconds after the keys are thrown, so it's going to be x, okay? So, for example, right when she throws the key, we would put 0 in for x, so that would be 9 feet above ground. At 1 second after she throws the keys, she'd be 9 plus 0.75 times 1, so her hands would be 9.75 feet above ground level. Okay, just to kind of give you an idea with that. Number 2 says write the functions f of x and g of x as a system of 2 equations and 2 variables. Okay, so here's our f of x. They already wrote that for us. So now we have f of x equals negative 16x squared plus 25x, oops, that's a 5, plus 5, okay? Write them as a system of 2 equations and 2 variables. In each equation, let y represent the height in feet and x represent the time in seconds, which it already does in this one, okay? It says graph the system of equations and use the graph to approximate the solutions of the system. We're going to skip that because the graphing is rarely, if ever, a great way to get a good solution. I mean, it'll give you like roughly the solution, but what we want to do is we want to actually solve this algebraically, which is going to be what 4 is going to ask us to do. How long after the keys are thrown will Lori be able to catch them? Assume Lori can catch the keys when they're the same height as her hands. So basically what we want to do is, so I guess we can draw the graph for 3 here, sketch the graph. So we have this here, this parabola, this negative parabola, and then the height of the keys are going to be going up. So basically there's going to be potentially 2 spots where she could catch those keys at. Okay? Or it might be just one, or it might be none if she didn't throw it hard enough. So I guess that graph is kind of helpful just to kind of get an idea of what we're doing. So how long afterwards? What we're going to do is we're just going to do like what we did earlier in this section here. We're just going to plug this here. Oops. Got rid of my squared on that one. Colored over the top of it. We're going to substitute that in because both of these really are just y's, right? So we're going to substitute y equals 0.75x plus 9 and substitute into this one. So we get 0.75x plus 9 equals negative 16x squared plus 25x plus 5. All right. Going to get one side equal to 0, so we're going to subtract 0.75x. Oops. Let's do that in the right spot. And then subtract 9. And we are going to get over here, we're going to get 0 equals negative 16x squared. 25x minus 0.75x is plus 24.25x minus 4. Now, I'm not going to even pretend to try to factor that one because that just looks awful. So this is definitely a great one to plug into the quadratic, which is x equals negative b plus or minus square root b squared minus 4ac over 2a, right? So in this case, we got negative, our b here is 24.25 plus or minus the square root of 24.25 squared minus 4 times negative 16 times negative 4. We can barely see that. That should hopefully show up. All over 2 times negative 16. All right, taking a heavy sigh, big breath, because this is going to be a lot of math to figure out, isn't it? That's okay. We got this. 24.25 plus or minus square root of whatever we get for this here. So let's do 0.25 squared minus 4 times negative 16 times negative 4 gives us 332.0625, I think. Is that right? Yeah. All over negative 16. Okay, now here's what I'm going to do with this. I'm going to actually figure out what this is as a square root. That's just going to give us a number. So we're going to do second square root. And I'm going to, instead of putting that thing in, I'm going to do second answer. It'll plug that answer back in for me. We get 18.22, we're going to call that. So really this is x equals negative 24.25 plus or minus 18.22 over negative 16. Whew. So we want to find out both of those answers. So we're going to do negative 24.25 plus 18.22 divided by negative 16. And we're also going to do negative 24.25 minus 18.22 over negative 16 and see what we get for both of those. Okay, so negative 24.25 plus 18.22. Divide that by negative 16, and we get 0.3768. So let's do 0.38 seconds. And then we're also going to do negative 24.25 minus 18.22. Divide that by negative 16. And we get 2.65 seconds. Okay, so how long after the keys are thrown will Lori be able to catch them? 0.338 seconds if she catches them on the way up. If not, then she can catch them back on the way down at 2.65 seconds. Okay. Let's see. Assume that Lori can catch the keys when they're on the same height as her hands. Explain how you determined your answer. So, again, we just talked about that. 0.38 seconds if she catches them on the way, as the keys are going up, and then also 2.65 when the keys are coming back down. Okay. Okay, so that's solving a system of equations. That's a word problem. That's kind of a tricky one, but hardest part for most people is going to be writing the first equation. Then once we plug them back in, then we should be okay. Okay. If you have any further questions on this, please feel free to ask. Thanks.